This lesson is titled Multiplication Properties of Exponents. Now there are two main words we want to define first, and the first one is monomial. So what is a monomial? Well, it is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. So the exponents have to be whole numbers that are positive. And again, it could be a product of a number and one or more variables. Alright, now what is a constant? A constant is a monomial that is a real number. So the number 10 would be an example of a constant, which is one of the examples right down here. So here's a couple of examples of monomials. Notice we have a 3 and an x. But it's the product of the two. So 3 in amongst itself is a monomial, x is, but even if you combine them as a product, 3 times x, which is 3x, that would be a monomial also. What you're looking for basically is that there's no plus or minus signs in between, and again that the exponents are positive whole numbers. So here, 2x squared, although you have an exponent, that's fine as long as it's all being multiplied, so 2x squared. And our third example here, negative 4x to the 4th, y to the 9th. Again, there's no plus or minuses in between those terms, so therefore that is one whole monomial. So here you have to determine yes or no, are these following monomials? Well, the first one, 10, again, is a constant, so yes. I'm just going to put a y because my handwriting with this thing is terrible. Y, yes. 10 is a constant, which is a monomial. Now the second one is no. F plus 24, and the big reason is that plus. This would be a sum of two separate monomials, but as a whole, it is not a monomial. The next one is yes. Again, all you have there is a variable with an exponent. Now notice on D, you have here a 2 in the denominator. You have x times y times z, so x, y, z on top, 2 in the denominator. This would still be a monomial, because technically I could bring that 2 in the denominator up front, and there's that invisible 1 in front of the x, and say that's the same thing as 1/2 times x times y times z. So this is still a monomial. And lastly, E, we have here another monomial. So it's okay that you have multiple variables as long as the exponents are positive whole numbers and that they're in the numerator and that there's no plus or minus in between. Okay. Now what is a power? I apologize for all the sniffling here. I got a little cold. A power represents the amount of times a value is multiplied by itself. So the example here, 2 to the third, that's not saying 2 times 3, that's saying 2 times 2 times 2. So you're multiplying 2 by itself 3 times. 1, 2, 3, which would give you 8. Again, I'm still learning how to write neatly with this thing. The next thing is x to the 4th. Again, you could break that up. X times x times x times x. Now, to simplify that, all it is itself, so x to the 4th. Now, notice we could turn 2 to the 3rd into 8 because that is a constant number, but x to the 4th we're going to leave as variables. Now, what happens when you multiply values that have the same base but different exponents, or even the same exponent for that matter? Notice the bases are 3, but we have exponents here of 3 and 2. Well, that's the same thing as writing 3 times 3 times 3, which is 3 to the 3rd, times 3 to the 2nd, which is 3 times 3. But notice here we just have 5 3's. So really it's 3 to the 5th. Now that leads us to our first property here. It says if you have the same base, x and x, and they both have exponents, what you can do is add the exponents. So when you multiply bases, you add the exponents. Now, that's with the variables with the same bases, or constants with the same bases. Notice on this first example it says 6 times n to the 3rd times 2 n to the 7th. Now, I'm going to break this down one little step at a time. So what we can do is rearrange. When you're dealing with only multiplication, you can rearrange however you like. Because if you think about 2 times 3 times 1, that gives us 6. If you switch that around, that still gives us 6. Even if you were to say 2 times 1, oh, not time. 2 times 1 times 3, it's still going to give us 6. So in whatever order you'd like to do it in, if it is all multiplication, then you can rearrange. So I'm going to rearrange these here. I'm going to say 6 times 2 times n to the third times n to the 7th. Now with the constants, notice we're just going to go ahead and multiply that. So that gives us 12 times n to the 3 plus 7. Again, when you multiply common bases, we're going to add the exponent. So your final answer would be 12n to the 10th. Now if you know what you're doing, you don't necessarily have to show this step every single time. If you know just to add the exponents. So here on B, we have 3 times that invisible 1. We have p times p to the third, t to the third times t to the fourth. Well, again, you do your constants, you do your coefficients first, the numbers out in front. So you multiply the coefficients, that would give you 3. Now you have p to the first. Don't forget, that's an invisible 1 right there. So 1 plus 3 is 4. 3 plus 4 is 7. So t to the 7th. And that would be your final simplified answer there. Let's do this last one. We have negative 4 times negative 6. And then we have r to the first. And then r to the fifth. So that gives us r to the sixth. X squared and x squared. So you add the 2's together and you get 4. Then you have t to the third, and again the invisible t to the first, which gives you t to the fourth. But don't forget, with those coefficients, don't forget to multiply. So negative 4 times negative 6 is a positive 24. And then you have your r to the sixth, x to the fourth, t to the fourth. And that would be your simplified answer. Okay? Now, let's take a look at the next thing here. What happens when you apply power to a term that already has a power? So basically, notice here you have an exponent on the outside of that parentheses. Well, again, a power is the amount of times you multiply something by itself. So in this case, this would be 3 squared times 3 squared times 3 squared times 3 squared, which we said when you multiply common bases, you add the exponent. So 2 plus 2 plus 2 plus 2. Well, what's a quicker way? Instead of adding them all, notice here, 4 times 2. There's 4 2's that we're adding. So that becomes multiplication. So you get 4 times 2, which is 8. 3 to the 8th. And then you would calculate that. So, which leads us to our next property, which is when you have a power on the outside, you multiply it by the power on the inside. Notice the base didn't change. You just multiplied the exponents. So here, simplify the following. Well, this is 2 to the 3 times 9. Let's see if I can write that a little neater. 3 times 9, which is 2 to the 27th, which is going to give us a big number when we calculate that. We get 2 to the 27th. And again, that's not 2 times 27, it's 2 to the 27th. Ooh, which gives us a really big number. 1, 3, 4, 2, 1. 7, 7, 2, 8. Again, the bigger the exponent, the bigger your number is going to be, as long as their base is bigger than 1. So, 134,217,728. Now, that's not the main purpose, is to understand this number. It's to understand how to get it. And that's 2 to the 27th. So here, we have x to the 7th to the 8th. So you multiply 7 times 8, which is 56. Well, this third example, notice we have 2 powers. Now you always want to start with the inside and work your way out. So we're going to apply that 2 first. So that gives us 2 to the 3 times 2, which is 6. And notice we still have the 4 on the outside, so then we multiply that again. So that's 2 to the 24th. Okay? So again, power on the outside of the exponent, or outside of the parentheses, you multiply the exponents on the inside. Now, what happens when there are multiple values inside the parentheses? Here, we just had x in the middle, or we had a 2 here, we had an x here, we had a 2 here. Well, what happens when there's multiple terms on the inside? Well, it's kind of like distributing. It's so here our example is AB to the third. Well, that's like saying AB times AB times AB, which gives us 3a's. So it'll be a to the third times b to the third. So notice that power of 3 right here went to both the a and the b. So our next property is when you have multiple terms on the inside, but a power on the outside, the power goes to all the terms on the inside. So x to the m, y to the m. So let's apply that here. Now there is a common mistake on this first example. People remember to send basically multiply the 3 times this invisible 1, and then we like to do the 12, but don't forget that the 3 also goes to that coefficient up front. So don't forget that the number up front, that coefficient also gets that power. So 3 to the third, so 3 times 3 times 3 is 27, and then we still have x to the third, y to the 12th. Now this next one, notice you have negative 2 to the 5th power. Negative 2 to the 5th. You have a, you have 3 times 5, which is 15. B to the 6 times 5, which is 30. But when you raise a negative number to an odd exponent, it's like saying negative times negative times negative times negative times negative. If you ever raise it to the odd exponent, it's going to remain negative. So negative 2 to the 5th. And don't forget, when you're plugging that in your calculator, put that in parentheses. So when you raise it to the 5th, your calculator should say, or if you don't always have to use a calculator, that'd be negative 32, a to the 15th, b to the 30th. Again, when you raise a negative to an odd exponent, your answer is going to be negative. When you raise a negative to an even exponent, those negatives cancel each other out, and so you end up with a positive answer. Now, but be careful with what I just said, because it's notice where that negative is. That's a horrible arrow. It's not that much better. All right, that negative is on the outside. That means we're going to handle that last. So we're going to apply here 2 to the 2nd, x to the 3 times 2, which is 6, y to the 7 times 2, which is 14. But we still have that negative, and a negative times technically a positive term on the inside ends up as a negative. So we want to get rid of that parentheses. So 2 squared is 4, x to the 6th, y to the 14th. So like I said, when you raise a negative to an even exponent, your answer ends up positive, but when there's a negative on the outside of your parentheses, that means this power of 2 here is not going to that negative at all. So you only apply this 2 to what's inside the parentheses. All right. Let's go to the next page here. Now, applying that to some geometric shapes. Here it says express the area of the circle as a monomial. Now the area of a circle is pi r squared, r being your radius, the distance from the center of the circle to the circle. This is what r is. Now it gives us a value here, 2xy squared. So what you're going to do is your area is equal to pi, but we're going to substitute this value in for r. And notice you have a square on the outside, but again, it applies to all three, the 2, the x, and the y squared. So you get pi times 2 squared, which is 4, invisible 1, so x to the 1 times 2 is 2, y, it's 2 times 2 is 4, and that's your area. Let's do capital A for area. Now, I personally like putting the constants, or the coefficients, up front. So I'm going to go ahead and move this 4 up front, and then put pi x squared y to the 4th. Now you don't necessarily have to write it in that order. You could have written it with the x squared y to the 4th and then the pi on the backside. It doesn't matter, both are the same thing. So again, I just like putting the coefficients up front. for my final answer. Now here it says express the area of a square with side lengths of 4x to the third y squared. So you have a square, and it says here's a side length of 4x to the third y squared. Well, if it's a square, that means they have the same distances or same length on all sides. And the area of a square is your side times side. So another way of looking at it, if it's length times width or side times side, since it's the same number, it's side squared. So the area is going to be 4x to the third y to the second squared. Therefore, when you apply your power, you have 4 to the second, which is 16, x to the third raised to the second, so 3 times 2 is 6, and then y squared, so 2 times 2 is 4. This would be your final answer for the area of a square with 4x cubed y squared as one of the side lengths. Okay. Now let's take this a little bit further by applying this and actually throwing on 2 of these. What happens when you combine properties to simplify expressions involving monomials? Again, step 1 is apply the powers on the outside of the parentheses. Do that first, and then you're going to multiply the like terms. So here, basically there's like a line here, not covering that too. And we're going to do one side and then the other, and then we're going to combine. So if you look at the right side, you have 3xy to the fourth on the inside squared. So again, the square applies to all 3 of those terms on the inside. So 3 squared is 9. X to the, again, invisible 1 times 2 is 2. Y to the fourth, but to the times 2 gives us 8. So that's our first parentheses. Now our second parentheses, negative 2, but now we actually have to take this one. This is going to cause us to take an extra step here, because notice there's an exponent on the inside. You can actually combine those first, so we can actually say that's to the 6th. So we can multiply those exponents that are both on the outside of those parentheses and multiply them. So you have negative 2 to the 6th. When you multiply negative 2 to the 6th, you get positive 64, and then y to invisible 1 times 6 is y to the 6th. And now that there's no exponents on the outside of the parentheses, we can multiply across. So 9 times 64, let's do that. 9 times 64 gives you 576. Notice you have x squared, but there's no other x's on the second parenthesis, so you just bring that down. And lastly, we have y to the 8th times y to the 6th. But notice we're multiplying the bases. We're not multiplying the exponents. When you multiply the bases, you add the exponents. That gives us 14. 8 plus 6 is 14. And that would be your final answer for that problem. Excuse me. Now let's look at the next one. So here you have that 3 goes to that 1/2. But if you think about it, 1/2 to the third, you're going to raise the 1 and you're going to raise the 2 to the third power. So that gives us 1 to the third is 1, 2 to the third is 8. 2 times 2 times 2. And then we have a squared, but times that other power of 3, so 2 times 3 is 6. B, 2 times 3 is also 6. There goes our first parentheses. And again, we could take this on the second one and say 2 times 2. We can cross that out and say that's 4, because we multiplied those 2 together. Okay. Again, the 2 times 2, we can rewrite that as a 4. So we have one term. So now let's apply 4 to the fourth. If you do 4 to the fourth, but it's a negative, but you're raising it to an even exponent, so your answer ends up positive. You get 256. B to the invisible 1 times 4 is b to the fourth. So now we multiply across. 1/8 times 256. So what is 256 divided by 8 is 32. And again, an eighth of 256, which means another way of saying that is 256 divided by 8 is 32. We have a to the 6th, but there's no other a, so we just bring that down. We have b to the 6th and b to the 4th. When you multiply bases, you add the exponent. All right. Now, a way of looking at this is there's an acronym that you can also use. It's MADS PM. MADS PM. And I'll explain that what each one stands for. You pair these up, and what we did today is the MA and the PM. So when you multiply bases, you add the exponents. Man, that's some bad handwriting. Sorry about that. When you multiply bases, you add the exponents. And again, we'll get to this next time. But when you apply a power on the outside of the parentheses, you multiply the exponents. So if that helps you to remember that, MADS PM, multiply bases means add the exponents. Apply the power, it means you multiply the exponents. If that helps you, then whatever helps, go with it. So that is properties of exponents involving multiplication. Have fun with that.